So, closer, okay.
It's like you're singing.
How's that? Pretty clear? Okay. So, survey to the audience. Who here is a student? And professors, faculty, and industry. All right, it's pretty even. And who's heard of Ford Motor Company? Okay. Not everybody raised their hands, so I'm going to assume you don't know Ford. Ford Motor Company, if you come to the U.S., you'll see a lot of our vehicles. I think South Korea has a pretty good auto industry of its own, so maybe we have a few less on the road here. But we've been making vehicles for a long time, well over 100 years now, and I'm in the Research and Advanced Engineering division. And so I want to tell you a little bit about our organization. First, a little about me. I grew up in New York. I went to college at Columbia University, studied applied math there, and I liked it. So I went and I studied more applied math in grad school at University of Arizona. University of Arizona, for those of you who aren't familiar with the program in applied math, it's very flexible, which is one of the things that attracted me to it, because I didn't have that clear sense of, I love this and I'm going to go and I'm going to study the wave equation and be an expert in one thing from day one. I kind of wanted this flexible environment where I could do any kind of work. And the way they have the program structured is when you start, you do your core curriculum, your standard applied math stuff, do your qualifying exams, but then you have the freedom to go and work with any faculty member on campus. Any engineering department, science department. I don't think you could work with anyone in history probably, but within reason, extremely flexible. And so I ended up specializing in operations research. And I've been very happy with that choice. The other great thing that I did during grad school was I worked at Target Corporation in Minnesota. And for those of you who may not be familiar with Target, does everybody know Walmart? So Walmart's a very similar business to Target. Their stores have tons of stuff, everything under the sun, whether it's electronics or groceries or clothes. And the work that I did there, it was great. It was about looking at a data-oriented way to make plans for products and stores. So thinking about like walking into a store in Texas and looking at the shelf where you're going to buy shampoo, and walking into another store in Nebraska and seeing what kind of shampoo they have there, and basically using a lot of customer data to influence what you put on that fixed space. And that experience really kind of changed things for me in terms of my vision of what I wanted to do with my career, and really highlighted a lot of what industry had to offer, because I was definitely thinking academia for a long period of time. And I didn't even have a final decision on that when I finished grad school, and I went down to Santiago, Chile for a couple of years and was there as an assistant visiting professor before I came to Ford 3 years ago. So Ford Research has about 1,000 researchers spread out different locations. Our main hub is in Dearborn in Michigan, right outside Detroit. We have a small lab we're starting up now in Silicon Valley. Everybody wants to be in Silicon Valley because it's an exciting place. In Europe, we have a lab in Aachen, Germany with a couple hundred people and some research activities in Dunton and Merkenich. And Nanjing, China is another area where we're expanding research right now. Okay, key technology areas. As you can imagine, an automobile company, we're doing a lot of research on things that are vehicle specific. So engines, building engines. How can you make better engines? We heard the talk the other day from Boeing about turbocharged engines. There's a group that does new types of fuel cell technology, building hydrogen vehicles, all types of different vehicle-related stuff. The math that I'm involved in is more in these highlighted areas of enterprise modeling, so business models, and environmental science and emissions. That's a real key area for the company right now, because especially in the US, we have a lot of regulation coming into place, and we need to increase fuel economy. And there's a lot of math that goes into figuring out how the company should plan to achieve those goals, and how they'll be able to do it in a cost-effective way with vehicles that they can sell. Okay, so a little bit about the types of work that we do. One of the things I love about Ford Research is it is a traditional, even though it's corporate, it's a traditional research environment in many senses. So we do discovery work. And discovery work is not necessarily something that's going to hit the bottom line right now. It's something with a big impact, potential impact into the future of the business. And it can be several years down the line. It could be even 15 years down the line. But it has to be a solid idea. And when we're exploring discovery projects, these are often great opportunities to collaborate with universities. We do a lot of university collaboration, which I'm going to talk about in another couple of slides. Advanced engineering work, I'm not involved in this. But this is, think about building new features for the car. So active safety features are huge now. It used to be that cruise control would set your speed and keep your speed. But now adaptive cruise control will also keep you in the lane. There's tons of work on all these features and different new technologies, whether it's connecting your cell phone to the car or new types of engines. What I do more, much more, is program support work. And this is kind of internal consulting, where we're being approached to help out with different business problems. A lot of it is process-oriented, things that we're already doing, but we could be doing in a more efficient way with respect to planning, creating decision support systems, so that the things that we build can be used by other people independently. So 2 slides on how I'd categorize projects. One type of project is a pull project. This is very typical of program support work. And basically, somebody in the company comes to me and they say, can you help me out with something? You know, we think we need some math in here. Let us tell you about the problem. And I'm going to talk about an example of that tomorrow, so I'm not going to go into detail now. But one of the keys here is it requires a lot of translation. You start with something very not well formed. A push project is kind of the opposite. And this is one of the ties to being more like a traditional research environment. It means that I, as a researcher, can go and come up with something in my head and say, you know, I think this is a great idea, and I'd really like to see it happen at Ford. And one of the things that separates, I think, the industry environment from the academic environment in this respect is if you're at a university and you're a professor and you think, I have this great idea and I'm going to pursue it, well, you might just go and pursue it. And you might make a bunch of assumptions about how you're going to pursue it. And instead of doing that, in the industry environment, what I do is, the first thing I do is I look for a business partner. And I try to find a person that might have a vested interest in this problem, who maybe not wanting to work on it directly, actively with me, but at least a sounding board, so I can make sure the ideas that I have are consistent with the way things are actually working, that I understand the operation, and that this idea that I've conceived could potentially come to fruition. So in terms of who my department and who my group works with, Ford has centralized groups for a lot of things in the company. So marketing and sales has a division. Product development has its own division. And we partner with everybody. And so this is the last slide I'm going to show you. And this is another very great thing about the Ford research environment, and something that I think is very unique amongst industry. So we have established programs for working with universities, and we call those programs alliances, which means that there's dedicated money allocated for this university work. And if I want to get some of that money, I can put a grant proposal together to do it. And there's a call for proposals every year. So April, you start pitching your idea. June, you submit initial short paperwork on it. August, you submit a proposal. And by December time, you know if you've got funding for the next couple of years to work on it. And so when you want to go into these projects, in my recent current projects, I've had a discovery type project with MIT on different types of GPS routing for electric vehicles. Currently, I'm working a lot on scheduling. So scheduling problems, and I'm collaborating with University of Michigan. I'm going to talk about that one tomorrow. It's a great project. In addition to these already universities that we're aligned with, we also have a general pool of money, which we call the University Research Program, that we can work with anyone. We could work with somebody in South Korea. And another way to get funding for university projects that fall into this general pool is department funded. And so Fadil worked with me last year, and we got some funds together to get an IMA industrial postdoc position. And so when we put these proposals together, we get a PI from Ford, so when I do it, that's me, and a partner faculty member at the university. And the last thing I want to mention about this is we work with PhD students very closely. And so I have a collaboration right now with University of Michigan where one day a week, the PhD student comes, works on site with me at Ford. This is not just an internship during the summer, although it's that too, but it's year-round. And the interaction is very close. So it's not, yesterday in some of the discussions, it was mentioned about like a consulting relationship with a university. But this is a much truer collaboration where the investigator from the company is heavily involved in the ongoing research. And I think one of the great benefits to that is the projects stay really on track and focused, delivering something that's going to be useful. So that's what I wanted to start off with as an intro.
Maybe this is a good time to ask a quick question to Daniel, if anybody has one.
Great.
Okay.
Take it. It was very clear.
So stick around for more questions later. Okay, Albert, you want to go next?
Well, when I had a first look at this topic, I was a bit worrying. What should I really tell you about impact of mathematicians in industry? We already heard a number of, let me call it, showcases, careers of mathematicians. So should I just add another showcase to show that also Siemens has mathematicians, quite a number of mathematicians, quite successful if you count this in careers. So I thought, for example, we do not question impact of engineers in industry. We do not question impact of electrical engineers or chemical engineers or whatsoever. Why do we worry about impact of mathematicians in industry? So all we here around have seen a number of these showcases of these examples. Well, there seems to be not a problem. So I somehow tried, first of all, to make another example, more from a managerial point of view, that there isn't a problem. There is a problem in another direction, that there is not enough mathematicians around. That's the key point I'd like to make, and then finalize with, what I think is the real question here. Well, impact of mathematicians in industry. This was the right one. Who has really impact in industry? At least impacts decision making in industry. And there are a number of these advisory companies. One of the most famous ones is Gartner, an information technology research and advisory company providing technology related insight and so on. So these are guys that usually tell the management what's important, what to do, what they should do, not only for one company, so it's in general leaders in industry, government, also government agencies, high-tech and telecom enterprise, and so on and so forth. So these guys have impact. And I'd like to share with you just two of the slides I made almost 2 years ago for an internal review what's going on from these guys' point of view. These guys, you may be aware, have these nice pictures of hype cycles for different technologies. And of course, we are now, I would call it, in a hype cycle of big data, analytics, and so on. So we just had a look at one of these in analytics. And the Gartner guys, even they question, is analytics just tools that compute numbers and graphs? Because this is a typical picture a manager has from analytics. He gets graphs originating from tools that somehow work with numbers, yeah? And Gartner warns here, cheap, easy computing, that's what we have nowadays, increases the importance of theoretical understanding, yeah? And the reasons why this is important, they mention, there can be an error in the software. Do not just believe tools. And there is an enormous gap between what they call computational results and understanding them and making out of them what to do. Well, their conclusion here is, or was in 2011, that until 2014, 80% of organizations will struggle to recruit the necessary talent to meet their analytics objectives. And also interestingly for me as a managerial guy in Siemens, they do not talk about human resources, they talk about talent. It's not just human resources. They really claim this is a talent to be able to do this. They go one step further then, this talent gap, a lack of talent was profound, and here first time shows up, they talk about mathematics, mathematical basis. So mathematics and mathematical, maybe this is our main problem, doesn't show up too often in job advertising or whatsoever in many companies. Well, there is another topic, I won't go into detail now, providing more self-service solution, but this also has to do with mathematics. We should be aware that results that we produce cannot be just one-time results. We have to provide solutions for engineers. So if you have a solution for a problem, that's nice, but it only has a long-term worth for industry if it's what they call it self-service solution, so that the engineer himself can work with this, or the guy who is doing the daily business. And they ask for some awareness for the problem environment, not just the single problem. Model management is a critical topic. I will discuss it in more detail tomorrow in my presentation. And also a key topic, data quality, especially uncertainty in data. If they talk about big data, it doesn't mean only a huge amount of data, but also usually quite, let me call it, dirty data or whatsoever. And then there is, again, their warning until 2040, it doesn't help to buy tools. You will not succeed with tools, so 50% of investment in tools still will be wasted because you do not have the right people to work with these high sophisticated tools. Well, so we are now in 2014, though it will be soon that I'm sort of checking did this fit, were this forecasts right? I would at least say the last one with struggling with getting the right people, I see is true for many companies. And even we in Siemens Corporate Research tried to increase the number of analytics guys. That's mainly discrete mathematics for mathematicians in a mathematical language. We already have quite a number of them, so I would think around 80 to 90 people. But it's really hard work to find good people and to increase the number. And there is a lot of competition because quite a number of companies at the moment are looking for mathematician. So it's like, I would say it ever has been. Even when I finished my PhD, I didn't have a problem to find a job. I don't know really about mathematicians that had problems to find jobs in industry over the last 20, 30 years. And I think so. This isn't the key. The key question is not to find a job in industry, not the problem that you won't have impact. I think the key question we have here is how do we want to support this impact? So from academic side. So it cannot be just, as I mentioned here, you can provide specific solutions, but you should have in mind industry in general is interested, if it's really an important topic, to take over the ability, in the most simple case by tools, but it's not only by tools, but also by the trained people, by the talent, as mentioned here before. And so I'd like to finish here my statements and wait for questions from your side.
Okay, thank you for provocative presentation. Are there any questions right away?
So Albert, I just want to make sure I understand the key question. So I think the key question is, you're asking is how are math departments or the math community going to help fill these needs? Is that what you mean by support this, or what do you mean?
I wouldn't focus it just for this needs, but this shows there are technology waves coming up. At the moment, a very obvious one was this big data and analytics topics. And then the question is, how does academia support the talent? Because they are really now, they have understood, it's not a question of tools that somebody provides a tool, but where does the talent come from? And it's obvious talent, you cannot create talent within 2 years in the numbers they at the moment claim. And we also know about the hype, it will go down a little bit again. So, but there is a very prospering area at the moment, and I'm pretty sure there will some more come over the next years.
Other questions right away? Okay, so Hyunmi, maybe you can go next.
Well, actually, since I don't have a presentation slides, I'll just speak. And there's a danger. If you don't have a slide, then you tend to go on and on for an hour to talk. So I'll try to discipline myself here and make it brief. My name is Hyunmi and I work for GSMA. I bet 99% of you here don't know what GSMA is. Can you raise your hand if you heard about GSMA? Oh, wow. I am surprised. That's right, I explained to some of you. It's a cheating. Okay, so GSMA, for those of you who I haven't explained yet, GSMA is an industry association that represents the whole telecoms industry in the world. So as members, we have all the telecoms companies. There's more than 800 of them, about 830, if we eliminate really tiny little ones who are not really worth having any membership. So more than 800 telco companies, the giant companies, are our main members who pay dues every year as a portion of their revenues. And then there's about 230 other corporations who's in broader telecoms ecosystem. So the device manufacturers, equipment manufacturers, these days even some entertainment companies and internet companies join as associate members to us. So what we do is actually, first of all, representing the telecoms industry in the eyes of governments and regulators. So we have a very strong public policy group who does professional lobbying to the governments of the world, which is quite a tough job because every country have very, very different regulation and government policies. That's one area we do well. Another area is working on industry problems. such as building the industry standard in telecoms, especially these days. Mobile technology is evolving so fast. There are new areas coming up every day that requires global standardization. So we're the organization who works with telecoms companies around the world to build these technical standards or commercial agreements, such as international roaming. So all of you, if you travel to another country, you can still use your mobile phone, thanks to us. So it's made possible because we have industry-wide standard and also global agreement to do the type of commercial deals amongst all the telecoms operators. So those things are one second area. The third area is holding biggest international events, such as Mobile World Congress. You probably heard about it because it happens every year in Barcelona, the biggest industry events where all the telecoms ecosystem companies gather together. So earlier this year, we had 85,000 attendees to our event. And then we also run different events such as Mobile Asia Expo that happens every year in Shanghai, and then a whole bunch of a little smaller regional events. So running through those events, we convene, convene the industry to create collaborational opportunities and info sharing opportunities. The fourth area, which to me is the most important, is setting the industry strategy and set the priorities, the directions for the global telecoms industry, and also running intelligence department that has a huge data platform, about 70, 80 industry analysts and economists there to do research and reporting of the industry. So we house probably the most powerful industry data in our data platform in GSMA Intelligence. You can look on your mobile to look for gsmaintelligence.com, and you will see real-time number updates about the industry also. And then in terms of a strategy, based on these intelligence, we set the strategy for the whole industry, which is quite tough because you have to know all corners of the industry, first of all, and that's where the intelligence part really plays a big role. So understanding the problems, defining the problems, and then providing the best solutions to solve those issues at an industry level, which comes out as industry project. So all the telco companies send their employees to work with us on certain problems to build it together. So that's what I do as a Chief Strategy Officer of GSMA. In that, I believe I am part of a great group that makes some impact in the industry in the whole world. And then I think I am doing it okay because of my educational background and my work experiences that I have built over time. Especially, I think the way I got to this point, got here, where all the executives in my company are Caucasians, Europeans. I'm the only non-European, non-Caucasian executive in GSMA, which I think is a very large part due to my background in math and applied math. So going back to my earlier years, after I finished my math degree in Korea at Seoul National University, I went to study applied math at Stony Brook. That's when I really had a wake-up moment that all the mathematical knowledge or the thinking process, the logic and everything is there to solve real-world problems. So a lot of you here are really, studying applied math or have studied applied math and applying it to real-world problems. I really had waking up moment at the time, and then I realized more and more as I was working on industry projects, who paid my tuition actually. I realized more and more how useful mathematics is to solve these real-world problems. And whatever problem you bring to me, I'll solve it for you. That was the mindset I grew when I was studying there. So I worked on quite interesting industry projects that include, building software to solve the geometric modeling issues with the oil reservoir, which ExxonMobil paid a lot of money to. Or some projects like from Kimberly-Clark, who makes diapers with new materials, and they wanted to understand the microscopic structure of the diapers that they are producing in the future, and make it most absorbent, very powerful, very thin, paper products. We also worked on brain structure. Someone talked about neuron and synapses. We did the modeling for those too. So a lot of applications, and whichever problem, whichever part of the industry bring the problem to us, we could solve it. And with that mindset, when I entered my first industry job, which was at American Express, credit card company, I was so freshly surprised, pleasantly surprised that behind the credit card, there's so much science. So it was actually basically working on huge pile of data set. American Express at the time, just from US perspective, all three major US credit bureaus provided whole data set, dump it into American Express every month. And from that data set that covers the whole US population, we filter through to find the best customer targets and send offers to them, customized offers. And then also with the existing customers, we match it with the credit bureau data all the time to segment the customers, to identify their needs, their behavioral patterns, and then provide best services for each customers. And I think that's why American Express for past 174 years have been such a profitable and great company, because there's so much science behind it. And I was very pleased to be able to be part of such a great work to bring science to the industry at the time. And then also in my department, which was decision science department, there were a lot of people who studied statistics or computer science, and vast majority actually came from business school, more business majors. I was one of probably the quarter of my department who majored in majored in mathematics. And I think I could I was known because of my math background or applied math background among the 250 employees in my department who was working on the same data set every day, because perhaps I could see through insights, filter through the whole pile of data set, and look through to find the best insights for customers, build my own algorithms to analyze them and to provide solutions, and bring that into actual real-world products that was applied the next day in actual markets. So the revenue increase was actually showing as a result. If you're in business, doing great math or great technology does not really make you go up the ladder of the corporate ladder. What matters is the actual result. So you either increase the revenue or increase customer retention or increase customer satisfaction. Only those results make you look great. So what you have to do probably is, with all your knowledge and skills, you really need to try very hard to bring the outcome that impacts the customer. And I think I was lucky enough to manage that. As a result of that, after a while, I was recruited by Shinhan Bank, which is the biggest retail bank in Korea, as a chief marketing officer, where I was asked to apply more data-based or analytics-based marketing and products. So it was another great experience in banking industry, which used to be less of using the data and scientific approach when marketing. It was more relying on TV commercials toward the mass, and also brute force targeting of the customers. And then after that, I was recruited by Korea Telecom as a chief strategy officer, where they also wanted to transform the company into more data-based, more analytics-based company, smarter marketing, smarter strategy. So they have offered me a job as a chief strategy officer there. It was also a time, which was a great time, when telecoms industry was really transforming from voice messaging oriented business to, am I boring you? Or is it just because it's right after lunch? So right after lunch, sorry. Yeah, so it was great. In the telecoms history, it was really great time of transformation because of a smartphone that was launched the first time in 2009 in Korea, the great Apple product, iPhone, that completely changed the core and fundamental of telecoms business. Because it's a smartphone, if it's an open platform, anyone can build their services on operators' networks, and telecom operators were very, very hugely challenged at the time. So they needed a new strategy, changing the direction of the company, and new way of developing the networks and products. So I was actually found by the recruiters of the world to do that job for the telecoms company, because I have fresh eye, I have experiences in analytics-based marketing and marketing strategies, so I could expand the scope of knowledge in telecoms after coming in. It's always easier to educate mathematicians with business rather than educating business people with mathematics. So, so I had the advantage of having the mathematics already, so that I could, add to myself more business areas, which was sheer joy. And then, after doing that for a while, I was recruited by GSMA, which was looking for someone who could bring really fresh, new energy and also intelligence into the company, so that we can serve the whole telecoms global industry better. For me, it was a huge opportunity, because I thought I was enjoying the work in Korea, but I thought it would be even more worthwhile if I could work and impact the whole global industry. So I'm just doing that. So I think the core message that I would like to give is everyone, those who are studying math or applied math now, have a huge opportunity for yourself to turn yourself into a business person. I call myself more of a business person, and I forgot about math, and everything. But still, I hugely appreciate the power of math, power of analytics and data. Try to hire more people with that background into my business. So there's a pending invitation to all of you.
Okay, thank you. You got an applause. Everybody else didn't.
Thank you.
So any quick question before we go on to the next speaker? Can you say a little bit more about how big your organization is?
My organization, GSMA, as a trade association, it's quite big actually. We have about 600 employees.
And it's all over the world?
Yeah, we are headquartered in London, where I am based as well, but we also have regional offices across the world, which in about 20 countries right now, but it's expanding with very rapid speed. So the number of employees are actually quite rapidly increasing. Yeah.
Thank you. So, Jeff, last but not least.
Last but not least. Yeah, it's working. So I'm going to get applause by saying that since I've already spoken, I'm not going to have much to say, so I won't throw it on.